Let's look at the P series. P series essentially would look something of this sort. Okay, now it will look like Sn n greater than or equal to 1, where your Sn will be equal to 1 upon 1 to the power p plus 1 upon 2 to the power p plus 1 upon 3 to the power p, and so on and so forth till 1 upon n to the power p. Okay, now this is your Sn for this series. For any n greater than or equal to 1, of course. Now let's see what happens when p is somewhere between 0 and 1. P is somewhere between 0 and 1, or might be equal to 1. If it is equal to 1, what does happen? Well, it becomes a harmonic series. So if it is equal to 1, then what will happen? Sn will essentially equal to 1 upon 1 plus 1 upon 2 plus 1 upon 3, so on and so forth till 1 upon n, which is harmonic series. And I have proved time and again that harmonic series diverges. Harmonic series is not convergent. I have proved that before. So let's see what happens between 0 and 1. Okay. Now, of course, your an equals to 1 by n to the power p. Now, this is positive, right? This is positive for any n greater than or equal to 1, right? This will be positive term. You can take n as anything and then its power would be positive, right? Anything means n natural numbers greater than or equal to 1. So, we have learned in our theorem that in case you have a positive, you have a non-negative sequence, the series given by the sum of the terms of that sequence converges if and only if it is bounded, right? So what we have learned, let me just write it for you. If an is a non-negative sequence, okay, and if you have a series in which your Sn essentially is a1 plus a2, so on and so forth till an, then Sn will, then the series will converge. The series will converge if and only if Sn is bounded. Okay, it's bounded. So that means that if it is not bounded, it will not converge. That means that if it is not bounded, then it is not converged. So let us check on the boundedness, okay? Check on the boundedness of Sn. Okay, let's check on the boundedness of Sn. Okay, so as we are taking p, somewhere between 0 and 1, what do we have? We have, in terms of n, what will we have? N to the power p will be less than or equal to n. Right, for any n greater than or equal to 1, right? Say 2 to the power anything between 0 and 1, take half, root 2. Root 2 is always less than 2, right? So for example, let me just write it here, like root 2 is less than 2. So something of this sort. So that will hold for every natural number, and this implies that if I just take the reciprocals, that would mean that 1 upon np is greater than or equal to 1 upon n. Okay, that's the relationship which we will have for all natural numbers. So in case I sum it up by summation, what will we have? We will have that 1 upon 1p plus 1 upon 2p plus 1 upon 3p plus so on and so forth, 1 upon np. And this will be greater than or equal to summation of 1 by n, which is 1 by 1 plus 1 by 2 plus 1 by 3 plus so on and so forth plus 1 by n. And this is, as I've mentioned earlier, harmonic series, which is divergent. So what we have essentially is that Sn is greater than or equal to some un, okay, and this un essentially is harmonic. So therefore this un is unbounded. It's unbounded, which implies if the smaller series is unbounded, that means the bigger series, okay, bigger series will of course not be bounded. So bigger series will be unbounded, okay. So what does this mean? This means that Sn is unbounded. Sn is unbounded, and which implies that Sn, the series, is divergent. Okay, so that means when P is in between 0 and 1, this series is divergent, this P series that we started off. Okay, so P series is divergent when P is between 0 and 1, might be equal to 1 as well.